The idea was to use just one source of data and use that one source of data for different purposes. Depository for this one source of data was our 3D models. We had the alignment for the railway in the BaneDK rail track. A clearance profile for the trains were defined in the same product in BaneDK rail track. And all the data we got, all the models we got from different disciplines, we put them together with these models. And then we had an overview about the project, what was supposed to be built. And then we could use these as assembly models for all different purposes. In this situation, we make a cross-section in order to make drawings or document what we are going to do. Same models were used for visualization and communication with other parties. Another challenge is complying with time and budget. Having these 3D models, our contractors were able to simulate the building process, the construction process. In this case, it is a railway bridge over a very crowded motorway. So using these models, they made some simulations which made it possible not to interrupt the traffic too much, and then optimize the whole process. Another challenge is always in that type of project is quantities. But having these models from different stages, we were able to put them together to find out what is the reality about the quantities. The contractors use the 3D models for the earthworks in order to find out how to manage the transportation of earth from one place to the other, and then optimize the process, and then reduce the CO2 emission too. Another challenge is control the consistency of the models. Putting them together, you can use Power Civil to make any type of cross-section in any interval. In this case, it is just 1 meter interval. And you have all the different disciplines together. Then you have an overview about, okay, what's wrong? Is there anything wrong? Or is it altogether fine? One of the major challenges we had was with safety and interoperability. When we have these design and build contracts making the civil works, they do not have any idea about what are the signaling objects, what are the electrification objects. So what we did was that we defined requirements for the free passage based on European standards and Danish norms. And then upon that requirements, there was generated a 3D model of minimum infrastructure gauge. And these, each time we got any models from our suppliers, we could put them together and document the free passage by making clash controls. It is the first time the independent assessor, our independent safety assessor, has approved this method to accept the documentation for free passage. It's first time in Denmark. I don't know if any other country have tried the same. So it was quite an achievement. And then one of the things we used our 3D model was for giving information to our bidders in the beginning of tender process. Making these simple visualization gave them an idea about what they were going to build. And then as well, communicating with authorities, it was much easier to explain them what we were trying to do, so they could have an better understanding of our plans. Another thing we used the models was to interface coordination with other contracts. In this case, to our electrification and signaling contract, to give them an idea about what we are going to build. We made these animations in the below part of this animation, you can see the position of the train and the speed at this position. And above, you can see the visualization from the driver's eye. Laser scanning is quite normal to use in that type of project we have to define the existing surface. But what we did use the laser scanning was to use them for visualization purposes. We developed a completely new method where we got all these 3D models from our suppliers, made them to point clouds, and then put the point clouds in these laser scannings and made the visualization. The reason we did it was that it is so time-consuming to make animations for 60 kilometers of railway. Using this technology, we were able to reduce the necessary time for this type of visualization 10, 50 times. Reduce the time. And then some of you have seen this one, making 360 degrees videos, also for communication with both with authorities, but also to give information to other contracts and the people living around the line. And then we use the models for supervision and inspection. It's actually something that we are still working on. Having these eye models, we were able to put them in Bentley Navigator and linking all the necessary documents or the related documents to each position. And now you can see she points to a bridge, and then there's a drawing of the bridge linked to this position. So it is possible to explore the drawing. And then it is a data sheet about the same bridge, information about the bridge. And then you can choose another location, take a look at the pump, and find a maintenance manual for the pump. Another thing which is possible to do in this environment is to make some redlining, to put some photos of the situation when you're out on inspection, and then link it together at the position, go back to the office, and put it back in Project Wise.